I did. Welcome back, algebrists. We will go over that in just a few minutes. Let's take a look. Now, kind of embarrassing, but I don't remember at all how to do this. Uh-oh. If I'm trying to write this equation, what do I need? Two things. I got 2 points. Sweet. So something in here is y1. I like it. Say yours louder. Slope. Man. Okay, I'll find slope. 6 minus 4, Mark, or 4 minus 6? Good choice. 6 minus 4 says Mark. And what do you think Amy has to go in the denominator as soon as we commit to 6 minus 4? 10 minus a negative change to a plus, 2. Okay, so that's 2 over 12. Simplified to be 1 over 6. Okay, we got our slope. I'm going to put a star next to it so I don't forget it. Does it matter which point I use? Which one do you think I should use? Smaller values are always nicer, although somebody in here inevitably is thinking, nope, I hate negatives, I'm going to use this one. Okay, here's my suggestion, especially with point slope. Negatives, don't shy away from it because we're going to do y minus something. The negative actually is going to make the problem easier. I will never think positive or negatives for that. I'll always just pick the smaller numbers. So let's plug in y minus, somebody said it, 4 equals, Praskovia, what was my slope again? 1/6. And let's see here, Cheska, what should I put inside here? X minus, so I used 4, so it looks like this one. X minus a negative, I'm just going to change it to a plus. All right, at this point, if all I was asked to do was find an equation, are we done? We have an equation. We do. Now, I think, and I don't remember because I didn't write it, but I think I probably asked you to solve it for y. Okay, so here I am. Then let's solve it for y. I don't know what to do. You want to distribute first? Yeah. Okay, so I won't even touch the left side of this equation, and let's distribute. What's 1/6 times x? Okay, quick question. Thoughts on writing this as 1/6 x? Okay. That's fair. Uh-oh. 2 over 6, does that simplify? 1 over 3 after we simplify it. We're almost done. What should I add to both sides of this equation, Joselina? If I want to solve for y, what would you add? Good. Now, this is going to look wonky. I'm going to write plus 4 on the left side of this equation. Give me a better way to write it on this side. 4 over 1 would work. There's a better way. I'll even do some scratch work. 4 over 1, but I want it to be what in the denominator? What did I really just add to both sides? They're both 4, right? They just look different. And why would I possibly make them look different on each side? Because I'm going to add the fraction. Yeah, we're just trying to do this a little bit more efficient. They gone, and let's see what we get. Y then is equal to 1/6 x plus 13 over 3. And look at that, we have it. Okay, I want to know if you had an answer, where were your mistakes? Because somebody made one, I'm sure of it. Added 4 twice. What do you mean? Like you just did it again? So you had a 4 right here? Easy mistake to make. King. So you subtracted 4 to try to get rid of it? Super easy mistake to make. Seabass. What do snitches get? Okay. All right. So looking at these. Again, I want to stress, I'm sorry, we probably should have done this stuff day 1 rather than just saying, hey, let's look at transformations and stuff, key features. This should have been done day 1. Next year it will be. Sorry if the first little bit has been stressful and I didn't realize that your line stuff was kind of shaky. That's my bad. Please forgive me. Okay. What do you Thanks. What do you prefer, slope intercept or point slope? Interesting. Interesting. Okay. There's another type of equation that we need to deal with. And this one, I've always seen people every year not like it. Okay. Last one. We've had slope intercept, mx plus b. We've had point slope. I'm not going to read that whole equation. The last way that we can write a line is standard form. Now, we are going to get a little practice sketching graphs here, but let's dig into it. Standard form of a line. Now, we're going to see standard form show up over and over. There is a standard form for lines. There's a standard form for quadratics. There's standard form for circles. Pretty much anything that we ever graph. Seabass. Not typically. Like if we need to because it makes a problem easier, sure. But normally that won't. Anybody remember standard form? AX. Okay. Plus BY
plus CY
equals C. This is it. Now, there are some rules. This one doesn't show up super duper often. When we eventually start writing our own systems of equations and trying to find minimums and maximums and stuff, we'll deal with that. But this form becomes pretty common. If I have two things that I'm trying to say, I use less than this, like, I don't know, almost like a fence idea, maybe we could use something like this if they were lines. So when we graph this, we don't have to write it down, but there's a few little characteristics that are typically held true. We always default to A being positive. Like it just always will be if it's in true standard form, but it could be negative. We would just be a little bit off of standard form. We could still graph it. The greatest common factor between these three things should be 1. There should be nothing in common because if there were, we would factor it and divide out on both sides. Okay, these ones, super duper easy to graph, super easy to graph. And we're going to do that right now. So let's graph from standard. Okay. I'm going to write one on the board here in just a second, and I want you to talk with your neighbors. Don't write anything. Don't solve the problem. I want you to discuss what's the route for how we would actually graph this function. So, 30 seconds after we get it written down, don't write it because I think that I know what you're going to say, but we'll see if that's true. Let's see. Do you guys know the prime numbers? What's the one's not prime? What's the first prime? 2. So let's say it's 2x plus, what's the next prime? 3y equals 5, and I'm actually going to pick a not prime over here. Let's say it's something wonky. You want to do 6? Or we'll do something, sure, 6 is fine with me. Okay, 30 seconds with your neighbors. If I just said, graph this, what would you do? Like, I just need an approach, not an answer, not a graph, just an approach to it. Starting right now. Okay, so you can't not quite like that. Couldn't do that though because okay. Real quick check. My gut feeling, I only spoke with one person here, but I have a feeling. How many of you guys immediately said, "Oh, I solved for y"? Okay, that's like 90-ish%. You can, right? You could solve for y. You could subtract 2x and then divide by 3, and you can get something in mx plus b. As we're looking at it, I don't want to do it that way. I think there's an easier way. There's a faster way that standard form always scares people, and everybody defaults to doing y equals. But let's not. Okay, you don't need to draw the graph yet, and I guess we're going to graph it, so we might as well. I'm going to graph it right here. Okay, now you guys default to this big square one. I'm fine with that. 2 quick questions. How many points do I need to graph a line? 2. And so that's easy. If I get 2 points, that's fine. We're going to do this without solving for y, just so you guys know. If I wanted to know when it crossed the y-axis, my y-intercept, what is the value of x anywhere in here? Okay, so check this out. I just want to think here. I'm going to make that comment a little bit. The y-intercept when x equals 0. And if that doesn't click, notice, if my graph crossed anywhere here, no matter what, point I'm at on the y-axis, x is always 0, right? So here's what I suggest we do. If x is 0, we would get the y-intercept. So with that in mind, let x equal 0. And then let's just see what happens. I get 2 times, what did we just say x was going to be? 0. So I get 2 times 0 plus 3y is still equal to what? 6. Do I really truly need to write this term even? Why not? Indeed. So there it is. It's gone. 3y equals 6. What is y?
2. 3.
So I'll divide both sides by 3. I get y is 2. Everybody on board with that? So check it. All I'm going to do is I'm going to say, okay, scale. There's 2. And I found my point. Is 1 point enough to draw this line?
Yeah.
2. Man, well that worked really nicely to get the y-intercept, right? What else do you think we get very similarly, equally nice? To get the x-intercept, anywhere along here, it happens when what? So the x-intercept, when y equals 0, can we just let y equal 0? Yeah. If we do this, it's 2x plus 3 times, what is y again? 0 for this try. It's gone, and that's still equal to 6. How do we solve for x here? Oh, okay. X is equal to 3. So check it out. I'm just going to go to where y is 0 and x is 3, and I'm going to plot that point. How many points do I have in my graph? How many points do I need to draw a line? Can I just draw the line then? Okay. We talked out a lot of this problem. We'll try it one more time. Is this faster than solving for y, you think? Depends on the problem, honestly, but you don't have to solve it for y. We can just graph it straight from here as long as we recognize that we have some key features like our intercepts and stuff. Can you tell the slope right here?
Yeah.
I mean, kind of. We could count it out, right? Okay. If you solved it for y, would you get the slope as well?
Yeah.
Now, in the end, does it really matter whether you graph it from the intercepts or if you solve for y? No. There's 2 options. Anytime that I'm given an equation like this, I will always do it like this because it's so much faster. Cool. All right. I want you guys to graph one for me. I said I want you guys to graph one for me. All right. Here we go. Let's say it's 5x. Was ours plus or minus before? It was plus. So let's do 5x minus 2y equals, I don't know, 10. Cool. I want you guys to find me the intercepts and graph it. Cool. Yep. So I wouldn't even write all this. Yeah, absolutely. If you're ever crossing the y-axis, no matter what, the x always red. Good. And if you're crossing the y-axis, it's always red. Yep. And we're just using that fact. So right here, I would just say let x equal 0. That automatically apply both sides. Did you have to invent? Yep, just physically say x right here. Write down x equals 0. And I'll show you what my work normally looks like. Okay, I'm going to demonstrate what my work would normally look like if I'm not being wordy with it. Did you guys get -5 for y?
Yeah.
And notice, I didn't have to be like big and fancy with all the writing and stuff. That was just for like everybody's benefit. I've got 1 point already. If y equals 0, what do you get for x? Would you like me to show work, or can I just say x is 2? Okay. These are my intercepts, right? So check it out. I'm going to think ahead on my graph. I need -5 and +2, so maybe I'll focus like this because I only need to see what I need to see. And just a sketch, not going to be crazy. If I claim this is -5, would you believe it? Especially if I put -5 right here, you will. If I claim then this is 2, Do you believe it? Boom. We're done. Is that faster than solving it for y? 100%. Do you have to, bless you, do you have to do it like this? No. Like, you can use whatever method you want, except blindly copying a graph on a calculator. Don't care if your calculator can graph. I know it can. Sweet. All right. So, review of this. Helpful. Do you want to go over our quiz? Cool. All right. I'm going to pause this.